So in this slide, we use a diagram to illustrate this idea of conjugated bonding and the pi star molecular orbital. What we see at the top is a schematic diagram of a conjugated polymer molecule. The dotted lines at both ends show that we are illustrating just a segment, one part of the molecular chain. And at each point of this molecule, where there is a dumbbell, it's assumed that we have a carbon atom. This carbon atom has got 3 sp2 atomic orbitals. And as we mentioned in the previous slide, they are used to form the sigma bonds. These are the strong covalent bonds which hold all the atoms in the polymer together. But since carbon has 4 valence electrons at the outermost shell, there is 1 electron which is not engaged in covalent bonding. And this is illustrated by the dumbbell shape on this diagram. These are what's called the pz orbitals, and they are oriented perpendicular to the plane of this chain molecule. Now, due to a principle in quantum mechanics which we cannot discuss in detail, and this is called the Pauli's exclusion principle, we find that when the pz orbitals overlap with their adjacent neighbors, the energy of the electron in the pz orbital will have to split. That means one energy level will split into 2, and then 4, and so on, into a set of very densely spaced energy levels. And there are actually 2 of these, 2 sets of these densely spaced molecular orbitals. The one at the bottom is called a pi molecular orbital, and the one at the top is called a pi star molecular orbital by convention. And in between the 2, there is a so-called Homo Lumo Gap. And this is very important because this gap contains no energy levels. And it is this gap which gives the conjugated molecules the semiconducting behavior. Because in a crystalline semiconductor, such as silicon or gallium arsenide, we have something very similar to this. And this is called the valence band and the conduction band. The valence band is similar to the pi molecular orbitals, and the conduction band is similar to the pi star molecular orbital.